Next is 2.5.2, the derivative of the cosine function. No new vocabulary here, but we do get the rule for differentiating the cosine function. The derivative of the cosine function is on the next slide. So before we get there, I want to repeat a bit of exploration 1 using the cosine function as our y value. So let's use cosine function here. And then in y2, let's hit the math button and use the numerical derivative option 8 and find the derivative with respect to x of the cosine function, and we'll evaluate that derivative at every x value so we do see the cosine function's derivative graphed. All right, so let's just go ahead and do zoom trig instead of setting up the window ourselves so we can speed this process along. That's option 7, zoom trig. So here comes the cosine function, and that appears just as we think it would. It's a sinusoidal wave, but alongside it now in red is the derivative of the cosine function, graphing a little bit more slowly because the calculator is finding the derivative numerically at each individual point along the x-axis, and it appears to have a relationship very similar to the original function. The red graph here is the derivative. It looks a lot like the cosine function or the sine function, but maybe either shifted a little bit to the left if it's a cosine, but if it's a sine, I think that's the sine function just kind of reflected about the x-axis. It's like an upside down sine wave. Generally, we would see at 0, 0 a point, and then it would increase from there rather than decrease to hit that maximum rather than a minimum. So I'm going to make a conjecture that the derivative is negative sine, and I hope you would as well. So let's get back into our notes here and go to the next slide and see, yes, we guessed it. We were correct. The derivative of the cosine function is negative sine. So ddx of cosine of x is equal to negative sine of x. So let's put that into use. And we're also going to recall here that the derivative of the sine function was positive cosine. So derivative of sine, positive cosine, derivative of cosine, negative sine. Now on to an example. We want to find the derivatives of a, y equals x squared sine of x, and b, a function called u, which is cosine x over 1 minus the sine of x. Let's start with part A, where y is equal to x squared sine of x. And I put in a dot for multiplication to remind us that we need to use the product rule here. So dy dx, or the derivative of y with respect to x, is equal to. So the product rule would say it's the first function x squared times the derivative of the second function. So I'm going to write ddx of sine of x plus the second function, sine of x, times the derivative of the first function, which is x squared. Now let's put in those derivatives. So we have x squared times a derivative of sine of x we know is cosine x, plus sine x times the derivative of x squared is 2x. We're going to remember that you cannot multiply into a trig function, so this is not sine of 2x squared, it's just sine x times 2x, and I'm going to simplify that a little bit and write my final answer as x squared cosine x plus 2x sine x. So that would be a perfectly fine answer. You may also notice that there is a common factor of x in those two terms. So if you chose to factor out the common x, you would have an equivalently good answer as well. So it'd be x cosine x plus 2 sine x in parentheses. But let's move on to part B. We have a function named u, and it's equal to the cosine of x over 1 minus the sine of x. And because this is a quotient of two functions, we're going to have to use the quotient rule to find our derivative. So du dx is equal to, we remember this rule, the quotient rule, as low d high minus high d low over low squared, or when we mean low and high, we're trying to say the numerator and denominator function. So low d high, that'd be a 1 minus the sine of x times d high, so times the derivative of the cosine of x, minus high d low, so the high function cosine of x times the derivative of the low function d low. That, well, derivative of 1 is 0, and the derivative of negative sine of x would then be negative cosine of x. The negative there plays like a constant multiplier. And this is all over the denominator, 1 minus sine of x quantity squared. All right, let's get into the derivative. So we still have a 1 minus the sine of x times the derivative of cosine x is negative sine of x. Notice my use of parentheses here helps keep everything in order and keep my distribution right. Next, minus the cosine of x, and I already found the derivative of 1 minus sine x there. I didn't use ddx. Well, that'll be okay. In this case, I'm just going to go ahead and leave it as negative cosine of x, so that on my next line of work, I can do all the distribution. So here's that distribution: a negative sine x times 1 and a negative sine x times a negative sine x. Okay, so that's negative sine x. And then negative sine x times negative sine x is plus the sine squared of x. Wonderful. And then we move on to a minus cosine x times negative cosine x. Well, these two multiplied together make a plus cosine squared x. And this is all still over a 1 minus the sine of x quantity squared. And finally, you may notice that there's a trig identity here. That sine squared of x plus cosine squared of x, what is that? It's 1. That's the first Pythagorean identity. So I can write then 1 minus the sine of x over 1 minus the sine of x quantity squared. And because we have a factor of 1 minus sine x in the numerator and the denominator, that whole thing can cancel. And that means we have as a final answer 1 over 1 minus the sine of x. I think that's such an interesting problem because remember the original function was cosine of x over 1 minus sine of x, and now the derivative looks really similar. It's almost the same thing except we've replaced the cosine of x in the numerator with just a single 1. And now we have used the derivative of sine of x and cosine of x in some examples.